All right, so we're live. This is kind of a unique episode. I'm not doing normally when I stream, it's either I'm working on the compiler or I'm working on the dog fooding. Recently that's been the movie app. But what I'm gonna do today or right now is, based on some feedback from some of you, I've been getting asked to do some live code review, which obviously, represents a decent chunk of my daily job. Hey Christopher, how's it going? So today, what we're going to be doing, this is a pretty interesting CL that we're going to look at. And a few disclaimers. Like one, the CL is about the runtime. So it's not going to be code review of like typical userland compose code. This will give you a fair amount of insight into how the composer runtime works, and might be interesting to some of you, might not be interesting to others. Another disclaimer is I did ask Chuck, who's the author of this CL, if he was okay with me reviewing this live. And he graciously said that it was fine. So we'll be looking at that. And then also another disclaimer, it's 5:20 p.m. for me locally. It's a little bit late to be starting a stream, but my typical work hours just shift depending on how life is going. So I think work-life balance is important, but if I have a certain time available, then I'll do that, and then various times throughout the day I may take a break and all that. It's one of the nice benefits of working from home. Okay, so with all that said, let's dive in. Let's maybe first talk about like what this is doing. Reading just the description here, it says reduce allocations attributable to the slot table, splits the slot table into an int array and an array of any to avoid allocating group information into the slot array, which avoids allocating the group object per group while still avoiding boxing group information. So to understand, maybe to break it down into some simple terms, like right now, the compose runtime has an array that we store data into, and the sort of data structure that holds on to that array we refer to as the slot table. And so one of the things about like arrays in JVM is let's say I have my array equals I'll say it's like an array of any, which is currently what it is, and then I need to give it a size. So let's say I have an array of any, and I initialize everything to null. What happens right now is if I store into the 10th index of the array, if I store an int, or actually let's do a bigger int. So let's say I store an int like that. That's gonna end up creating bytecode that calls integer.value of and then this, right? So in this case, this is an int, or like this is in terms of JVM, this is like an int primitive, and then this is an integer. And so all of these things get boxed. And the problem is that a lot of the data that we store in this array, based on just the the way the runtime works ends up being integers. And so we want to have as few allocations as possible that are attributable to the runtime. And so this was a big source of them. And so the idea was that we can have that array, but then we can also have an int array. And this is basically an int array of or something like that. I don't remember the API, but the point is that this now is an int array, so it's held contiguously in memory. And so not only is this a bit faster, but it will also avoid these value of calls. And the idea is that we have both of these arrays, and so the data structure that we called the slot table, it will now kind of manage both of these arrays at the same time, and we'll be pulling from the int array for various things, but then like the arbitrary data that comes in from like userland code, it will end up in this array of any. And so that's sort of like the overall idea. And so Chuck's been working on this for a while, and it was big effort. And so this is the first time I've looked at this CL. I haven't looked through it all yet. So I'm going to be kind of seeing it with fresh eyes as well. I've up until this point just sort of understood the general idea of the project. So let's dive into it. First things, we have these current.txt files, which indicate public, like a change to the public API of Compose. And so this is what we use to track the public API of Compose. And so if we have changes here, that means that this technically is like a binary breaking change. We're still in alpha, so that's like okay. And so we want to make as few of these as possible, but if we're gonna do them, now's the time. And a lot of this change probably could, like if we were really, really worrying about it, we probably could do it without breaking the API, but it might not be as elegant if we did. And since we have the ability to do it, we can do that. So it looks like we used to have this location API, and now we've got 2 APIs for this. This is for an anchor. So an anchor is the array that we store information on. It's actually like sort of a gap buffer. So the array is bigger than the collection that it represents, and there's like a gap of empty values that we kind of move around. And to deal with that, to be able to access a value in that array, you might need what we call an anchor, which if it's in front of the gap, it's basically like, okay, what is the index from the top? And if the value is located after the anchor, then it's okay, what's the distance from the bottom? And the idea there is that when we move the gap, we can just very efficiently update these anchors so that it's an easier way to kind of have like a pointer to this position in memory or in the array. Sir Derper asks, will this be recorded? It's too late here right now. Yeah, so I'll be recording this stream. Right now I'm streaming to Twitch and YouTube. It should be on Twitch for 16 days or something like that, and it'll be on YouTube indefinitely. Okay, so I mean, these public API changes seem fine. We're basically saying, okay, the idea of location before, we're now thinking of to index 4, which is the purpose of an anchor, is to convert something into an index, like a currently, to convert the anchor into an actual index int for that array. Hey, Danny. You know, some pretty simple things here. I'm not sure why. I guess this object key, oh, I guess that makes sense. It's like before, you know, I mean, we could keep this as a property if we wanted, since it was read-only. Oh, I guess it is an object key, but then there's a get object key. Yeah, all right. I'm not quite sure why that happened, but okay. Well, a lot of small public API changes here. I'm probably going to skip over the API changes for the moment and kind of come back to them once I have a bigger grasp of the overall picture here. So let's maybe dump in, like, let's dive into the meat of this, which, you know, I think the slot table, that's that data structure. This is where I think all of the meat of this CL is going to be. Obviously, the line counts kind of indicate that. And you can see here from the line counts, we've added quite a bit of complexity to this data structure, because now, you know, instead of a single kind of array to hold these things, we have these parallel arrays, and the logic, I guess, to get them is going to be more involved. So, you know, has a cognitive overhead cost for sure. But also, so I mean, just to, I saw some preliminary benchmarks from this, and so this CL represented a you know, a significantly or statistically significant improvement in performance, but not huge. So I think it, you know, single-digit % or something. But the allocation improvement, so the memory usage of Compose dropped by like over 20% or something. So that was like a pretty big deal. Okay, and it looks like Chuck also went to some trouble to document this data structure better, which is nice. So I'm just going to read through some of this. Ignoring its gap. Yeah, so an address, I guess, is similar to an index, but I guess we're using a different word for index. The logical index of a group or slot in its array. Yeah, so this is good to identify this, because if you have a gap buffer and you have something below the gap, what do you call its position? Because its index in the sort of semantic collection that it represents is its, you know, array index minus the gap size. But if you want to get something out of the index, then you need the index with the gap size. And so Chuck's kind of calling this out here and saying that, you know, address is what we refer to when we have the absolute index. So the thing that we can say array bracket index to get. So that's an address, versus the index represents kind of the index in the semantic collection, like if there wasn't a gap. An anchor, which I already kind of explained what that is. Auxiliary data that can be associated with a node and set independent of groups or slots. This is used by, yeah. So auxiliary data. This is let me see. I mean, I guess Chuck's probably explaining it better than I can, but yeah. Like if you end up using, for instance, remember, if you pass in arguments to the input parameters of remember, that would end up resulting in this type of data. Okay, and so then data is like kind of a bigger group of things. It represents not only the kind of auxiliary data that was passed in from userland, but also some of the data that Compose runtime itself is managing, like the node. So like in this case, like the layout node, as well as the key of the group and some stuff like that. So that's nice. I guess I just want to call out, I really appreciate that Chuck did this. I mean, because this is, you know, this is a big deal. This data structure is kind of at the heart of the Compose runtime, and it's complex. And ideally, you know, if we're like, this is probably, you know, the last major refactor to this data structure that this class is going to get before we're kind of locked into, you know, API stability. And, you know, if people are working on this long term, you know, like years from now, you know, these type of comments matter. Like there's a lot of times where, you know, you're looking at stuff and you're like, why did people use this term, or how is this different than that? And so these definitions are really helpful. So I appreciate that. Okay, so when you compose a hierarchy, all of like we use something called, we refer to as groups, which is being defined here, but like you can think of that as like we store this entire hierarchy in a flat array, and we use these like markers to indicate boundaries of a group. And there's various pieces of information that we need to keep about each group in order to like do a lot of other things. And so in this case, the group fields is that set of information, and we'll see like we used to store that in a class. But I think that what Chuck did is he removed the class and made it so that this all is just stored as consecutive ints in the int array. So this data, it ends up being the key of the group, which is sort of like a hash. It also is a node count, so the number of nodes that are below that group, and then the group size. So that's the number of like entries in the array that group consumes. And then the parent offset. I'm actually not quite sure what offset that refers to. If it's like where I guess like how many indexes away the parent group, the start of the parent group is. I'm not sure if that's what that means, but that's how I'm guessing right now. And then anchor to the group data, and flags to indicate if the group is a node, if it has auxiliary data or has an object key. Yeah, so not all groups will have like auxiliary data or more complicated keys and things like that. So this is all very helpful. We went through index already. Yeah, so in Compose, when you use like, you know, let's say I have a composable function. Then I can call another composable, and sometimes what you might do is you might say let's just say this is a string or something. I might use the key composable to kind of uniquely like identify the things underneath it, so that that ends up following it. And like where this ends up being useful is like you know, user and users or something. So let's say this is users, doing something like this. So this is like a pretty reasonable thing for someone to do. And so what this does is key is like an intrinsic composable in Compose. And when I pass this in, what this does is it means that the group that is being created here, it's not only going to be identified by the source location hash, but it's also going to use this user.id to create a compound key. And that's what Chuck's referring to here with this object key. And the reason that there's a meaningful difference here is because the key can be stored in the int array because it's always an int, and that's the overwhelming majority of groups have key just normal int keys. But then an object key, it's going to be like a real object in JVM, and because it can be anything, it can represent like any data. And so we would need to store that on the data array. And then a slot. So you know, a slot is basically an element in this array, basically. Okay, so that was helpful. Let's read through this. All fields and variables referring to an array index are assumed to be index values, not address values, unless explicitly ending in address. Okay, fair enough. For simplicity and efficiency of the reader, the gaps are always moved to the end, resulting in index and address being identical in a reader. Okay, that seems fair. The public API refers only to index values. Address values are internal. Okay. And just for context, a slot table has there are two sort of companion type classes associated with it, which is a slot reader and a slot writer. And so the idea there is that during composition, we ought to only need a slot reader, and that's because composition should be thought of as a kind of read-only operation. It ends up producing a change set that can be then applied with a slot writer, and this will end up being like much more important when we start doing things with Compose in multiple threads and stuff like that, where the difference is really important because we can have multiple slot readers open on a slot table at the same time, but only one slot writer. Okay. So array to store group information is stored as groups of group field size. Array of an inline struct. Yeah, okay. So I think that this groups array, this is the int array that we've created to parallel the slots array. I guess basically the idea is that we're storing all of these the only thing the int array is really used for is like the groups. And so we used to have this group class, and like one way you can think of it is that like we've just sort of inlined the group class because all of its fields were basically ints. We've essentially inlined it into this array. The slot emblems for groups start at the offset returned by data anchor of groups. Okay. And continue to the next group slots or to slot size. Last group. When in a writer, the data anchor is an anchor instead of an index, as slots might contain a gap. Okay. So again, this is like the number of active slot readers, which, there's probably some sort of like think of it like a mutex, I guess. Not really a mutex, a semaphore. So, and then this is whether there's a writer. This is our array of anchors. Okay. So it's interesting that this is what we do to return is empty. So I guess it makes sense, right? Like this is the number of groups. So we've got our read and write function, which we had before. Can open a reader. I guess the reader has like a close method or something, probably. Okay. So we can open a reader and open a writer. Makes sense. That's how you get an anchor. This is how you get the index. I guess is an index always, or is an anchor always pointing to the slots array or the groups array? Well, that makes sense. So an anchor, I'm not sure. I guess we'll find out. Maybe an anchor. Well, where was this? So anchor.location. I mean, I guess one just bit of feedback here is I'm not really sure why we're using both check and require. Okay. So owns anchor. All right, that makes sense. I guess, like, you know, at any given time we can have more than, you know, multiple slot tables, and it would be weird if we get into some situation where we don't, where we're like using one anchor for the wrong slot table. But I guess probably, like, reading into this, it seems like the more likely scenario is just that whatever the anchor was referring to is no longer part of the table, which it seems unfortunate that valid. I don't know. I'm curious where we need to use this and where this kind of came from. So Danny says require throws a legal argument exception, check throws a legal state exception. Use require to validate params, use check if state's not good. Okay. Makes sense. So the require is used on the parameter, so that seems to make sense. Chowsler says, hey, this is a cool idea. I want to stream my code reviews now so I don't have to think so hard. Yeah, I don't know if it's, I'm not sure I'm thinking less hard than I would during a normal code review. It's actually, it's kind of interesting. It is requiring some cognitive overhead for me to kind of say out loud some of the stuff that I'm thinking, as well as kind of realizing what sort of things might need to be explained to some of you. So I'm going to comment on this and just kind of say, like ask where this came from, like why. This is an anchor index. Use anchor balance determine. So I think based on Danny's comment, I'm gonna discard this change because it seems like that's a good enough answer that check is for state exception, requires for an argument. So that makes sense. So this is to close the reader. Okay. It kind of feels to me like should be like SlotReader.close instead of SlotTable.close with the reader passed in, which would allow us to avoid this check. I don't know. This is for closing the writer. Used internally by SlotWriter, move from swap arrays with a slot table target. Table target slot table is empty. So Danny asks, what if SlotReader and SlotWriter implemented closable and in write and read instead of let, it can use. I was thinking about that too. I suspect that the actual code patterns for using the reader and writer don't end up that way, but I'm not sure. But I was thinking the same thing, and so maybe I'll just go ahead and suggest it and see what Chuck says. And then, you know, maybe one reason would be that I think closable, is that a JVM only thing? Closable. Yeah, so this is for java.io. Okay, I wonder, I'm not sure that we have access to it because this is a common module. So actually that's probably why we're not doing that. But we could implement a similar, yeah, this is a common module. We could implement a similar interface, but I'm not sure it's because yeah, I mean, I don't know. This isn't typically used by userland, but this still is public API, so it is something. Well, but all these, I guess this is maybe another reason. Or you know what? This might already work this way because this is internal. Whereas, you know, the open reader is public, so I think SlotReader might have a close method. So I'll wait, and if it does, then I'll resolve that. That's for closing the writer. So I mean, this is kind of interesting. So I guess the slot writer dot move from, I guess maybe we like pool slot tables. I didn't know that we did that. We'll have to check that out. So this is reasonable. Like, so this is like this verify well formed function, which sort of like, you know, helpful for debugging and testing and stuff like that, where we can kind of verify at a given point in time whether or not the slot table has the shape that we expect it to. So this is nice. I'm not sure I'm gonna read through all of this, but you know, it's useful to be able to do that. Okay, so this is nice that we have this as string here. I don't think we had that before. I kind of want this to be public because I mean I think it's a reasonable API contract for us to honor long term, and I kind of like, you know, I want other people to sort of be able to do this as well. So I don't know. Okay, so this is just more of the as string implementation, which makes sense. Yeah, keys, nodes. Okay, these are all just debugging things. So anchor here is, let's see. So we've got a location, which is an int. Okay. Kubernetes tracking is removed. I feel like I asterisked this before, but I guess we need this to be a reference because we want it to, we basically want to be able to save the anchor on things, but have like this integer update because it'll change over time. So it's important to have it be a reference type. Okay, slots, anchor index, okay, makes sense. Yeah, because if you have a slot writer, then I guess the index can be different. Is that right? Maybe. So this, it looks like this is something that is Kotlin standard lib should have a build string function, which is essentially just this. Suha says, "Good to see you live at this time. Suits for me." Where? What time zone are you in, Suhas? Or what time is it for you right now? Australia. Wow. So what time is that? 12 p.m. Okay. Yeah. I mean, I don't actually normally do that much coding at night. I used to work a lot later hours, but I mean, not that it's that late, it's 6 p.m., but like I don't know, just always stuff going on now. But my wife's taking care of the dog at the moment, so I've got a slightly free afternoon and wanted to get this review out, so just kind of made sense. Yeah, no worries. I was just reflecting on it myself. Okay, so now we're into the slot reader API, which has a table. Interesting. I don't know why. That's kind of weird. I'm not sure why it would. 3 a.m. here. Oh my gosh. Abdelilah, what are you doing up? Go to bed. That's too early. Or late, or I don't even know what to say, early or late, but it's too much. This seems weird, I guess. I guess this is an effort to keep these things private on SlotTable. What do we got? Groups, private set. Well, no, it's accessible. 3 a.m. is most productive time for some people. Gosh, I don't know. I mean, when I was in college, it would be pretty typical for me to be up at 3 a.m., but I don't know if I would call it my most productive time. Just sort of a necessity of life at that point. But hey, yeah, I mean, everyone has their own, you know, ideal ways to work, and it's fine. Abdullah says, I'm working on a KTOR backend for my final degree project. Oh, cool. What kind of a degree is it? Is this like a computer science or software engineering or what? Without noise, you're more productive. Well, you've got the noise of me droning in your ear if you're watching this stream, so should I be quiet? Okay, so it seems weird to me that the slot reader, like the constructor requires like groups and slots, because it can just grab it in an initializer. It seems like that's a simpler way to do this. Groups val. Yeah, it's one of the things that always bothered me was like a lot of the degrees. You know, a lot of people go and learn computer science, and that's like the, you know, the sort of canonical track or something. But you know, a lot of the stuff you learn in computer science is I mean, it's useful as a software engineer, but it's not really training to become a software engineer. It's only sort of tangentially related, and I think that more universities should offer offer software engineering tracks. I mean, it seems like similar to me, like the difference between, you know, a physics degree and a mechanical engineering degree. Like they're clearly related, and you know, learning physics or something might help you be a mechanical engineer or an electrical engineer or something like that, but they're not the same thing. And I've seen some universities, like I know the University of Waterloo does a software engineering track that seems really good, and I just wish it was more common. Oh cool, you're using Compose for the mobile part. Man, that's a bleeding edge software engineering curriculum. I like it. Okay. So all these things are there. And then what happens? So this is the slot reader. Okay, so as we're composing, the compose code will call like start group, end group, stuff like that, like as your composable functions execute. And so I guess when you call start group, what current is what is the group that would be created when you do that, or when you start that. Current end. Yeah, so I guess this gets set. The number of times begin empty has been called. I don't know what begin empty is. I'm gonna have to keep that in mind. I don't know what begin empty is. I'm not really sure even what this empty count is used for. That's weird. Okay. Let's see, the current slot of parent. I feel like it's a little bit weird to me that current and current slot mean pretty different things. The current slot of parent. Like what is I guess as we're like going through the slot table, we've got like our current slot, but then when we go up, I suppose we need to then increment current slot or something. I'm not really sure that it's not obvious to me why this is needed, but so the current slot minus groups.slot anchor of parent. So Abdullah says, I agree. Here, some degrees are starting to offer more specialization. For example, there's a whole degree dedicated to game development. Oh, that's cool. No. Yeah. It'd be interesting to yeah, I wonder what are the, like, how many degree is. So does your degree have a specialization? Groups that parent anchor. Like this kind of weirds me out, because when I think of anchor, I think of like an anchor of the class, and this method, I guess, is returning an int because it's getting subtracted. And so that makes it sort of hard to read for me. Oh, 4 options. So I might comment on that. Let me see. Let's search for it. Slot anchor. So address. Interesting. So Andre says that his degree was focused on networking, basically substituting usual program courses for Cisco and Friends. Yeah, Andre, where'd you go to college? I think it is common, but I think Abdullah is right that it's not very common in the U.S. for some reason, and I wish it was. All right. Count 1 bits. Oh, I forgot about that. This is. Okay, so this is gonna be kind of gnarly. All right, what I want to comment here is this method is returning an int, but the name of it feel like it should return an anchor. What was your thinking behind this naming? I think all of these functions are going to be fun to go through in a bit. Okay, let's go back up to our spot, wherever we were. Oh my gosh, lots of code. Okay. Hold on 1 second. All right, I'm back. I've got a dog with me. Let's see. I don't know how easy it is to see him, but he's back there. Man, that camera's so dark. I'm surprised. It's like really hard to see him. There he is. Good boy. All right. Let's see, where were we? So Andre says, so he went to college in Finland. Maybe in Europe it's more common. Delilah is asking how it works in the US. Not sure. Here it's 4-year degree, consists of 2.5 years. Everyone has the same subject, and 1.5 you can choose between computation, network, distributed systems, hardware stuff, project management, and software engineering. Interesting. Yeah, I think I mean it could be different now, I guess. Like my understanding was that at least in the US, most computer science programs don't offer any sort of like official specialization. Now, like once you get into the upper level classes, you can take like specific things, but I just think in general there's much less of a focus in computer science curriculums to like preparing you for like industry software engineering. It's much more sort of academically focused, and which I think is great if that's like what you're into, but it's just weird because the software engineering industry puts a lot of weight on computer science degrees a lot of the time, and I think that a software engineering degree might put a new grad in like a much better position to be immediately impactful and productive for most companies. So I just think it's a flawed system, I guess. Okay. So the parent index of turns the parent index of index. Okay, so that means for slot of index, this, okay. This will give me the parent of it. I guess that makes sense, but yeah, I just had to read that like 3 times, so I'm not sure that's a great sign, but okay. All right. So I think I have the general idea here for the slot reader. I'm gonna jump ahead to the slot writer, which might have some more interesting kind of things going on here. Abstract keys. It's weird. Okay. the diff here is like kind of all over the place. So, I mean, it's interesting that this does node here, else empty. Like, how does is node work? Groups to is node. Oh gosh, all right. What I want is this. And then like this is the kind of thing that'd be like helpful to have like IDE level code navigation here. So is node does all of this. So it grabs something from the int array. So it just looks at the bit mask. Okay. So that makes sense. So this is, I mean, this ought to be a constant time operation because it's just looking for something at some index. Okay. Where was I? Yeah, so this ought to be pretty cheap, and then yeah, I mean, so this is all reasonable. Okay. So key info. So interestingly, key info is no longer an internal Compose API. Not sure why. So we no longer hold a group, which makes sense because it used to have all of the information of like the group in it. Which maybe that's why this got removed, was because group was the internal API and it, well, no, but it was internal. So then it used the internal, yeah, okay. So maybe that was why. So seems like if you're going to change the name to object key, then the doc should also get updated. All right, so now we're on the slot writer. So I'm going to recommend the same thing here. Same recommendation here for avoiding the necessary constructor parameter. Okay. This is a weird calculation. I'm not sure. So it's the overall array size, so the number of groups minus the gap length. Whoops, what did I just do? Okay. I don't know what, I just accidentally refreshed the page or something. Here it is. Ugh. Browser's really struggling. So I guess like I'm curious if it's advantageous to have the group gap length like be like in terms of groups field size instead of just actual array size. Okay. So we've got an int stack here. Start stack, end stack, and node count stack, which I can see why that would be needed. Stack of the groups that have been explicitly started. Group can be implicitly started by using seek. Oh, I see. Okay. I guess one of the things that I kind of want is like it feels to me like maybe some of the naming here is different than for slot reader. I'll have to like double check, like maybe put them side by side or something, but it seems like the definition, like current slot versus current, like this seems weird. If this property is just to get the current group, then why have it at all? Like that's consistent with what current was on the reader API. So I mean, it would make sense for the names to be the same, and current group is maybe a more consistent name, but it seems wrong to have this extra API for essentially no reason. So current group index to address. Okay, makes sense. Like, I wonder if it would make sense to have like a current group address property or something. Maybe not, I don't know. Like, I wonder how many times this is called. So Delilah asks, is current group constant or variable? If it's constant, it wouldn't make much sense having that current property. It's variable, so it changes, but it still doesn't make much sense because all the getter does is call the getter of the other property. So I'm not sure I understand that. Okay, so this gets us the object key for given an index. So we get an address. Check to see. Okay. If the object key exists. If it does, we get the, okay. So node returns node at that index, null. Okay, makes sense. So we've got a parent property, which is the index of the nearest group that contains current group. Okay. And it's initialized -1, makes some sense. Whereas the parent that accepts parameter was group.parent. Okay. Okay, Seems reasonable. Okay, so here's the close method on the writer. Yeah, Abdelilah, I mean the I think current group, I guess current group is private already, but like I thought that this was, it was already marked as private set, but you're right. Maybe I'll add to this comment here. Can we just have a private as property instead? By the way, are these pull requests available to everyone, or does it have restricted access? Yeah, these are all public. They're out there, so you can look at them. Let me. I don't remember if I linked to this in the beginning of the stream or not, but here it is if you want to look at it yourself. Okay. Yep, no problem. So I guess this is some of the interesting things. I can update a value. This kind of weirds me out to just have this like set, call it like a. It almost looks like a syntax error to me, but it's not, obviously. But so having a top level set function. I mean, I wonder if. I mean, it's fine. So I guess this updates value, and does it return the old value? What does skip do? Where's skip? Skip the current slot without updating. Slot table is inserting. Empty slot is added, and skip, then return empty. Yeah, okay. Excuse me. Okay. I guess so one thing that's kind of weirding me out is like we have an update aux and an update, but they both accept any. So I'm just trying to figure out like when I would call one versus the other. Update and update aux. And do I want is update and not update aux. The other thing is this seems like very similar to what set is. Is that right? Yeah, data index to address. Okay, so set the set takes an index. Whereas this takes an address. Slot side address. I wonder slots index. Okay. Okay, so we have two sets, skip and seek. You seek by an amount, which is kind of interesting. I mean, that's probably semantically correct, but like it doesn't seem clear to me if seek should take an index, so like you're seeking to a specific index, or if you're advancing by some number. Seek and value it. I might first think that it is seeking specific index versus advancing by an amount. Okay. Yeah, I mean, because here you're seeking to an anchor, so that's more like the seek to a specific index. Here we have seeking go to this particular index, which demonstrates the point of the previous comment. Perhaps this seek the previous method should be named advance. Advance by. Okay, skipped current group N, that makes sense. End insert. Okay. So we've got all of our start, stop type stuff going on here. Aux is empty. Okay. Start group. Okay, this gets into some hairy stuff here. Start group and end group. All right. So I'm gonna. It's almost 7. I'm getting like a little bit hungry. Gonna probably stop for tonight. But you know, this is fun. People definitely let me know if this, I don't know, was useful, interesting to you at all, or anything like that. You know, there weren't a lot of live viewers on this stream, but I also wonder if part of that was because of the time of day. So let me know if this was useful. I'm interested. I'll be picking back up on review of this CL at a later time. Not 100% sure if I'll stream it or not, but you know, we got through like a decent chunk. So yeah, it's kind of interesting. And guess I'll close the stream with maybe a shot of my dog here. Enzo. Hey buddy. He's like, I don't care about you. All right. Well, thanks everyone. I will see y'all later. Have a good one.